Hi, Harry. Today we're going to talk about a very important topic in programming, how our programs can make decisions. It's called conditional statements.
Making decisions. They can do that too.
JavaScript is a very structured and logical language. It has special constructions that help make decisions based on the situation.
Like road signs at a fork when you don't know where to go.
Exactly. The main sign is if. It checks if something is true, and if it is, it performs a certain action.
I don't quite get it.
Imagine you're at a fork in the road. You have a condition. If it rains, depending on whether the condition is true or false, you choose one of the paths.
And what paths can there be?
In the simplest case, either you go one way if the condition is true, or you do nothing if it's false. Like saying, if it rains, I'll take an umbrella. If there's no rain, you just walk without an umbrella.
Got it. If then.
Exactly. In JavaScript, the if operator works the same way. We give it a condition, and if that condition turns out to be true, a certain block of code is executed.
And what does a condition look like?
A condition is a logical expression that can be either true or false. For example, 2 is greater than 1. That's true. 5 is less than 3. That's false. We can compare numbers, strings, check if something exists, and more.
Like asking the program a question it can answer yes or no.
Exactly. The if operator is like a gatekeeper that only lets actions happen if it gets a yes answer.
Can you give a real-life example?
Of course. Imagine standing at your house door. Condition: if I have the key. If yes, you open the door and go inside. If not, you stay outside or look for another way in.
The door only opens under a certain condition.
Exactly. The block of code that executes if the if condition is true is like the actions you take after entering. Taking off your shoes, turning on the lights.
And if the condition is false, the program just skips that block?
Yes, like the gatekeeper not opening the door and you simply moving on.
But often, if one thing doesn't happen, you need to do something else. Like with the umbrella, if it rains, I take it. If not, I just go for a walk without it.
Perfect example. For such cases, we have the else operator. It goes together with if. If it rains, take an umbrella if block. Otherwise, else block. Go without it.
So else triggers only if the if condition was false?
Exactly right. It's a backup plan. If the first condition isn't met, the else block executes.
Like if I don't have the key, I ring the doorbell?
Exactly. The key condition was false. So the backup plan, ringing the bell, kicks in.
So if checks the condition, and if true, does one thing. Else says, if not, do something else.
Exactly. It lets our program choose one of two possible paths, depending on whether the condition is true or false.
Are there other types of conditions?
If checking, else alternative, else if additional checks switch many options, like a big road fork. Don't worry, we'll go through them all.
Wow. It really feels like decision making. I'm ready. What's next? Triple forks.
Well, Harry, since you're ready for triple crossroads, let's dive even deeper.
I'm all ears.
Sometimes one if and one else just aren't enough. There can be many options. If it's raining, take an umbrella. If it's snowing, wear a hat. If it's windy, put on a scarf. And if it's sunny, put on sunglasses.
So you need to be able to choose between several paths, not just two.
Exactly. And that's where else if helps us.
Else if. How does it work?
Imagine you need to get to work, and you have several ways to get there. You look out the window and check, is it raining? If yes, you head to the garage to grab the car. If not, you check the second condition. Is it snowing? If yes, you take the SUV, and so on.
So the program checks the conditions one after another?
Yes, and as soon as one condition is true, that's it. No need to check the others. You pick your path and move on.
And what if none of the conditions fit?
Then you can use a regular else at the end to handle the nothing match situation. It's like a sign that says, if nothing fits, go back home.
Sounds like a game of questions. If it's red, do this. If it's blue, do something else. And if it's neither, don't touch it.
Exactly. Else if helps a program make complex decisions when there are multiple options.
And what about switch? I've heard of it, but don't really get it.
Switch is like a big dispatcher station. You come in with a ticket, and the dispatcher looks at it and says, if it's a ticket to London, take train 1. If it's to Paris, train 2. If it's to Rome, train 3.
So switch checks the value and sends you on the right path.
Yes, switch works especially well when you need to compare one variable against different options. It's much more readable than stacking lots of if-else statements. You can think of switch like a menu in a cafe. Different choices depending on what you ask for.
And what happens if none of the tickets match?
That's when the default block kicks in like a message. If nothing fits, go to the reception desk.
So switch is like when I walk into a cafe and say, I'd like. And there are a few options: coffee, tea, juice. Depending on what I ask for, I get the corresponding drink.
Exactly. The expression you give to switch, I like, gets compared to each case coffee, tea, juice. As soon as a match is found, the related action is taken.
What happens after the code for the matched case runs? Does the program keep checking the other cases?
Here's an important point. By default, after a match case runs, the program falls through to the next case and keeps executing. To prevent that, you usually put break command at the end of each case. It's like a stop signal telling the program, done here, exit the switch.
So if I ordered coffee and there was no stop, they'd bring me tea too?
Exactly right. Break stops the program from continuing into other cases.
And what if the value doesn't match any case?
That's what the default block is for, the backup plan.
Wow. Now I see that programs aren't just lists of commands. They're whole systems of choices and logic.
Exactly. And the cleaner you build your crossroads and paths, the easier it is for the program to do its job.
Looks like I'm already starting to map out my own roadmaps in my code.
And that's wonderful, Harry. Next, we'll learn how to make those roadmaps even smarter and shorter. Okay, Harry, we've covered the main crossroads and stations in the world of conditional statements. Now let's reinforce our knowledge and see how we can make our roadmaps even more efficient.
Awesome. I'm really enjoying this journey through the world of conditions.
Look, when a program needs to make a choice, it uses if operator. It checks a condition and decides whether to execute a certain block of code.
Like a security guard at a door. Got a pass? Come in. No pass. You wait.
Exactly. And if you want to plan for an alternative, what to do if the condition doesn't work out, you add else. It's like a plan B. If you don't have a key, you ring the doorbell.
Got it. And if there are several options, then else if comes into play.
Right. Else if allows the program to check a chain of conditions, like a series of doors. Is this one open? No. This one? No. That one? Yes. Come in.
And if none of the doors open?
Then you use a backup option, a simple else at the end. It guarantees that the program won't hang if no condition is met.
Okay. And switch. That's like a dispatcher at a ticket station?
Exactly. Switch is used when you have one value that needs to be compared against many options. Like in a cafe, based on your order coffee, tea, or juice, they give you the right drink.
And to avoid a mess, you should write break after each case so the program doesn't fall through to the next?
Yes, break acts like a stop sign. Stop, we've done what's needed, don't go further.
And if none of the options match, you use default?
Absolutely right. Default is like a general plan for if nothing matches.
Hey, is there a way to simplify long chains of if-else?
Of course. When conditions are simple, you can use a ternary operator, a shorter way to write it.
Ternary. We already talked about that.
Yes, just a reminder. It works like a mini version of if-else. For example, instead of writing, if it's raining, take an umbrella. Otherwise, go without it. You can write it all in one line. It's raining ? Take umbrella : go without umbrella.
Like a quick shorthand.
Exactly. The ternary operator looks like this. Condition question mark action underscore underscore true, colon action underscore underscore false.
And if I need to check many different conditions?
Then it's better to use regular if else, or switch for clarity. The ternary operator is only good for very short choices.
Can I use switch with numbers or only with strings?
You can use it with both numbers and strings. The important thing is that you're comparing one value to different cases.
And what about logical operators? They help with conditions too, right?
Correct. Let's quickly review. It means both parts must be true, or means at least one part must be true. Not means not. And it flips the value of a condition.
So like, if I have a key and the door is open, then I go in?
Exactly. Or, I have a key or someone is home. Either way, you can enter.
Got it. Programs aren't just commands. They're real systems of decision-making at every step.
Exactly. And the clearer you build those conditions, the easier it is for the program to understand what you want.
I feel like my roadmap has become much clearer. Thanks, James.
You're doing great, Harry. More exciting journeys are ahead. Get ready. As always, I encourage you. When you get home, practice all this at the computer to better absorb the information.